Let's take a closer look at how the dendrites work in the simulator. Start up the simulator lab first. It comes up with the standard simple neuron, but we don't need all that. Let's clear it out to make it a little less confusing. Select Synapse and Dock. It puts it away. Soma, Dock. Axon, Dock. And we'll leave the scope connected to the dendrite and the dendrite connected to the step. Okay. Turn that step down to its reset value. And you can see very little output from the dendrite with 10 connections from the step. Let's look at the inner workings of the dendrite. It's a length 100 micrometers and the diameter is 1 micrometer. That's normal for a dendrite. You can reset this button to clear it back to that in case you've changed it. The membrane resistance is 3 megakiloohms. That's very high resistance, and 3 centimeters, 3 picofarads of capacitance. This is the, let me turn on the hints. This is the lambda space constant, and this is the tau time constant. The transit time for these calculations turns out to be 2 milliseconds. In other words, it takes 2 milliseconds for this step to pass through the dendrite and onto the oscilloscope. The input is shown at 0. That's, you don't see it because it goes by so fast at 1 millisecond pulse width, but the maximum is 10. So if I change this up a bit, you see that jumps up to 12. So that's the normal. And this shows the output going up and then back down. Okay, let me move this back up to 3, 4, 5, 6, 7, 8, 9, 10 milliseconds. You can see that improved the output quite a bit. If I improve it even more by increasing the output width again, the output of the step width. Now you can see it producing a normal curve. This is the charge time for the dendrite. This is the discharge time for the dendrite. If you look, take another oscilloscope and put it right there and click on the input. You can see the input comes up, charges. When it turns off, it discharges. So that should give you a little better hint of how the dendrites do their job.